Hello everyone. Welcome back to my channel. Today, let's deep dive into the system design of payment gateway. Before starting that, I would want to talk about a bit of the terminologies that we want to cover about the payment gateway systems, starting with PSP. What do you mean by PSP, which is Payment Service Provider? In simple terms, payment service provider is nothing but a company which helps the merchant, let's say for example Amazon, to process the payment from different payment mode. Let's say as a buyer, if I place any order, the merchant, as in the Amazon, it will help me to complete the payment, right? That's being done by the PSP. Some of the examples of PSP are Stripe and PayPal, etc. The second one is payment gateway. Now, in our today's topic, we are going to do a system design of payment gateway. But what exactly is payment gateway? It's nothing but a tool which connects the merchant with the payment service provider. Now, the third terminology is payment network. What do you mean by payment network? It's nothing but a system that moves the money from one bank to another during the payment processing. So, in our case, we know about companies like MasterCard, Visa, etc., right? So, the payment service provider, it basically connects with the payment network to move all the money that has been transferred from merchant to seller, etc., from one bank to another. The fourth terminology that we are going to focus on is double ledger system, which is nothing but a balance sheet. When we are talking about balance sheet, it's nothing but the mode to record the payment. So let's say the money is being debited from one account and being credited to the another one, right? All these will be getting logged in into one balance sheet, which is called as the double ledger system. And finally, we have the fifth term is the reconciliation system. So reconciliation system is nothing but double checking the payment records with the PSP and the payment network. So these are the five terms which are key to understand before designing the system for payment gateway. Now, once we have this understanding, I would want you to know about the flow that we have in payment gateway. So basically, there are two flows. One is pay inflow and second one is pay outflow. Pay inflow is basically when the money is getting moved from buyer's account to the merchant. In our case, the merchant is Amazon. Whenever a customer places an order, the money moves from buyer to merchant account. That's called as pay inflow. And the seller flow, when the money moves from merchant to the seller account, that's called as the payout flow. Okay, so now I think we have a basic understanding of what are the key terminologies and the flow in payment gateway. So let's go and start designing the payment gateway system. So whenever we perform any system design question or answer that, the first thing that we list is the FRs and MFRs, right? So talking about the functional requirements. In our case, the first functional requirement would be basically what would be the different modes of payment. So we can ask this question, and basically in our case, we would want to support the credit card, debit card. It can be bank transfer, it can be wallet transfers. The second question that we should think about is how do we want to store the PIN information, the personal information of the customer? Do we want to store in our system or not? Let's keep this out of scope, and for now we can tell that okay, all the PIN information will be stored in the payment networks. So it would be basically the Mastercard or Visa, whichever we are going to prefer. They will be storing all the information of the customer. Once this is answered, the third thing or the third thought should be how about the processing? Do we want to perform the payment processing by ourselves, or do we want to use any third party API? So talking about the payment processing, for now let's use the third party API like Stripe or PayPal to perform the payment processing. The fourth question should be how about the scope of the application? Do we want this particular application or the payment gateway to act as a global application or a local one? Why am I asking this particular question is based on this, our next question would be to support the currency. So basically, do we want this particular application or gateway to be at global level, or do we want to support multi-currency in our payment gateway or not? So let's keep this as yes. And finally, I would want to show about the different flows as well. So do we want to talk about both pay in and pay out flow as well or not? So do we want to include the payout flow as well? So let's keep this as yes as well. So this is what the functional requirements look like. We have skipped one major point, which is about the traffic. So what should be the traffic of this payment gateway? Let's say for now, we want 1 million transactions to be performed in a day. Uh, so this would be the expected user traffic that has been given in our interview. Once this all has been listed, how about the enterprise? Since we are designing a payment gateway system, the first thing should definitely be our system should be reliable, and second should be it should be fault tolerant. So these two should be very key to consider while talking about the enterprise of our system. And not just this, we would definitely want our system to be scalable as well. Uh, Now, since we have the functional requirements and the non-functional requirements, I would want to talk about the back of the envelope uh, estimation. How to calculate the back of the envelope estimation. So we know about the user traffic. The traffic that has been given to us is 1 million transaction, right? So once we have the 1 million transaction, how do we want to calculate the TPS, which is transaction per second? It would be nothing but 1 million divided by 10 to the power 5, which will be approximately at around 10 TPS. And considering the peak hours, let's say it would be TPS into 3. So my peak TPS would be 30. So we have now the back of the envelope estimation as well. Now, once we have the back of the envelope estimations, I would want to talk about the APIs. How do we want to design the APIs? So while designing the APIs, the main API that we are going to talk about will be the post API of the payment. So it would be version payment with the request of so what all a request do we want to send? One thing would be customer ID for sure. Once we have the customer ID, we would also want to send the order ID. We would want to send the amount that we have to send. What would be the currency since we are going to support currency system, so we have to indicate what should be the currency of the system. Once we have indicated the currency, we would also want to include whether the um, ledger has been updated or not. So uh, whether it has been updated or not, once the ledger is updated, also I would want to showcase the payment orders, but it would be part of the order ID as well. So we don't want to include that. It can be put into separate uh, way. Other than that, do we want to include anything else? So yeah, one thing would be definitely the payment mode. What would be the mode of payment that we are performing? And what else uh, is payment successful, or are we going to talk about the payment status? Okay, so this would be some of the request parameters talking about the response. So for our response, we would want to have the payment ID, we would want to have the payment UIs. And not just that, we also want to send the customer payment details, right? So here we would want to send a payment token. So since we are not storing the PI information, using the PI information, we'll create a token, and based on that token, we'll perform the payment processing. So this is what the API should look like. Now, based on the API, let's create the database schema as well. So for our database schema, we would want to have the payment table. For our payment table, we would want to have payment ID, we would want to have the customer ID, we would want to have the amount details, the currency. Um, then, as I said, it should have the payment token. It should have the payment status, um, payment mode as well. Is the mode of payment? Is it credit card, debit card, bank, or wallet? And yes, about the order ID. So order ID, customer ID, these would be foreign keys. Payment ID would be a primary key. So yeah, this would be primary key, and these would be foreign keys. So we can always create a table for customer wherein these two, the customer name, phone, email address. Same goes with order ID. So an order can consist of various products. So again, this would be again a foreign key. And yes, about the ledger updates as well. So whether the ledger has been updated or not. So yeah, this should be the data schema that we have. Now, once we have the API, we have the database schema. Let's go and deep dive into our high-level design. So, how does our high-level design look like? Let's take a basic component that we have for our system. Here from system, we'll have a API gateway. From our API gateway, will once the user places an order, so let's say here we have the user placed an order. From the API gateway, it should go to the payment service, right? So I would go here and write a payment service. Now, what would be the task of payment service? The basic task of the payment service is to authorize the user and see its risk identification as well, whether the user is a delinquent or not, and all those information. Once we have those information, so the API gateway provides the authorization, it sends to the payment service. Once the payment service receives the request, it sends the request to the PSP provider. So we'll create another service for our PSP. And PSP, like I said, it can be Stripe or it can be PayPal. Once it sends the request, the registration request to the PSP, it should basically receive a token. So once the PSP check the request, it will send back a token to the payment service. Why do we need this token? So currently, when the user places an order, the payment service it places the order by the checkout service, right? Once the checkout service is being sent, it's sent to the payment service provider receives a token. Based on that token, we would show a hosted page because we don't want to store the PII information in our database, but via token, and at the same time, we would want to send the details to the PSP to store the details. So it would go and show up on the PSP hosted page. So let's create one component. This, yeah, let's create one component for the PSP hosted page. So this would be our PSP hosted page, and how do when it would show? So based on the token, so once the user has the details, so the request with the help of request and token, it will show the hosted page. Based on the hosted page, when the user put the account information in everything, those requests will again go to ESP to start the processing. So in order to start the processing, we'll send a request to the PSP. So yeah, these requests would be sent here. And once the PSP completed the request, when it received the request, basically it sent the details to the payment network. So we will have a payments network. So in our case, the payment network can be MasterCard or Visa, right? The user will send the details to the payment network, complete the payment, and once it completes the payment, it will send back the status to the PSP hosted page with the response that is payment successful. So yeah, once it receives the success response based on whatever token is there, it will go and show the payment status page back to the user. So once again, let's see. So the user places an order over here. It goes through our API gateway. From API gateway, it goes to the payment service. The payment service will send the request to the PSP to generate a token. From the token, it will request for the PSP hosted page. Without the token, it will start the processing request, the payment processing request for PSP. It performs it send the details to the payment network to transfer the money into the account. And based on the status of the payment, it will send back the status to the hosted page, and it will show the status page to the user. So this should how the details should look like, but at the same time, we haven't taken into account the database. So where are we storing all the data? Not the customer PIO data, but the payment information we need to store, right? So for that, let's create one database store. So we'll be having database schema for us since there is not a lot of data and we don't we having a lot of join operations or complex query, we can always store this into a NoSQL database. And since this is going to be a write heavy database, so for this I would want to use Cassandra uh, as our database to store all the information. Okay, so all the information from the payment service will get stored to Cassandra. Now again, since it's a lot of writing and not reading, so for my scaling perspective, I would want to have the master-master architecture rather than the master's slave architecture. Now, for those who don't know what is master-master and master-slave architecture, basically, it's the sort of replication process wherein we keep multiple masters, or we'll keep one master to perform the write operation, and then all the slaves, it will get replicated at the periodical time level. So for now, since it's very write-heavy application, I would rather want to have a multiple master, which will be in sync for the write operations. So this is how the response or the high-level design should look like for the payment. Now, once we have this high-level design, there should be one approach that we would want to follow, which should deal with the scalability. How are we do we want to deal with the scalability information? So over here, what we can do is we can basically add a queue. So instead of having sending the information directly in some format, we can keep this in async format, and um, with the help of a queue, and basically it can be Kafka or any queue strategy wherein the user will send the information. Uh, it will send the information and receive the token. So this way we can handle the scalability of our operation as well. So it will basically send the registration request, and here it will generate the token. So this way we can handle the scalability process as well. Now, since we are talking about the payment, one more thing we would want to talk about is how do we want to show the delay in process. Sometimes what happens is there we might get delay in the payment processing, right? So for that, how do we want to handle it? I would say that in that case, since we are getting the payment success response, based on this, we can send one URL link to the customer to check the payment status page, and at the point of time, whenever they want to come, they can see what is the status of the payment processing that they have made. The last thing I would want to talk about is the idempotency, because what happens if the customer by mistake clicks on the place button twice? At that point of time, what we want to do is we want to send an idempotency key with our request, so that based on all these information, the request that we are generating, we should create an idempotency key, and at later point of time also it can check and make sure that there is no more than one action taken for a particular request. So yeah, I think this is all about the high-level design of the payment gateway that we have. We have talked about the terminologies, we have talked about the payment flow, DFRs, NFRs, API design, and database, and finally the deep dive into high-level design. If there's any other question that you want to ask about, please put that in the comment section. And yeah, we'll take it from there. Thank you so much, everyone. Have a good day and see you later. Bye bye.